In these two examples, we're going to be graphing linear inequalities. They're inequalities because they have a greater than sign, less than sign, greater than or equal to, less than or equal to. A couple things we need to be reminded of here. If we have a less than or equal to, we're going to shade below the line. If we have greater than or equal to, we're going to shade above the line. And so that has to do with the kind of less than, greater than. Then if we have less than or greater than, they don't have the or equal to, we're going to use a dashed line when we graph. That means that the solution does not include the line. The line would be the equal to part. So we used a dashed line to show that's not, the line isn't part of the solution. If it's a less than or equal to, or greater than or equal to, if it's got the or equal to part, we're going to use a solid line, because using a solid line shows that the line is included. We do need to remember, if we have to solve any of these, that when we multiply or divide both sides by a negative, we have to change the inequality sign. Now these rules right here, these apply for once you have it in slope-intercept form. So you don't go by the original. So when we look at 18, this isn't in slope-intercept form. So once we change it into slope-intercept form, that's when we're going to look at the signs and figure out how it's going to go. So really, we just graph these things normally to start with. So remember, this is our y-intercept. We start with our y-intercept, which is -3 on the y-axis. And then we use our slope, which is 7/5. Slope is rise over 1, so we're going to go up 7 from this point. 1, 2, 3, 4, 5, 6, 7. And then right 5. 1, 2, 3, 4, and 5. And so this is going to be our point here. This is just a greater than. It doesn't have the or equal to, so we're going to draw a dashed line. And the fact that it's greater than means we're going to shade above the line. So we would shade up here. The next one, we need to actually solve for y. So we would subtract 6x from both sides. Don't forget we have a negative here, so negative y is greater than negative 6x plus 1. We don't want negative y, we want a positive y. So we're going to divide both sides by -1. Dividing both sides by -1 is like dividing each term by -1 because of common denominators. We divided by a negative, so we must change the direction of the sign. This is positive 6x minus 1. So now looking at this, this is our final equation in slope-intercept form. So we're going to start at -1. That's our y-intercept. Then our slope is 6. Well, we can think of that as 6 over 1. Or -6 over -1, if you want to think of it that way. We can go up 6 and over 1. Or we could go down 6 and left 1, which would get us a little bit off the graph. Once again, this is just a less than. It doesn't have the or equal to, so we're going to use a dashed line. If it had the or equal to, we would use a solid line. And then we're going to shade below the line because it's less than. It's a less than sign in our final. Our original has a greater than, but we don't look at the original. We look at once it's in slope-intercept form. Now below kind of seems hard, but this does have some slant to it, so we just think, even though it's slanted, something below a point on the line. So let's look at this point right here on our line. Think of below it. Here's a point below it, so we want to graph or shade this side of our graph. And that is graphing inequalities. So make sure you put things in slope-intercept form, remembering to switch the direction of the sign if you multiply by or divide by a negative. Use a dashed line if you don't have the or equal to, a solid line if there is an or equal to. For greater than, you shade above. For less than, you shade below.